Hey guys, hoping all is well with everyone. So in this video we're going to be looking at our question of the day here, and this one states to solve the quadratic equation by factoring, then select all possible answers. You may check your answer by graphing the equation. I'm going to show you a little bit differently of checking your answer that doesn't relate to graphing it. But our equation that we're going to be looking at is x squared plus 6x plus 9 equals 0. More than one answer may be correct. Mark all correct answers. Now, before we go into any of the step-by-step approach or starting of how we're going to solve this problem, there's a couple things I want to point out with this particular quadratic equation. And it's going to help you set yourself up for success to look for these things when you start to solve these. The first one is that the quadratic function x squared plus 6x plus 9 is equal to 0. In a lot of situations, you're going to be given scenarios where it's not, and that makes it harder for you to solve for the solutions. And I'll tell you why. Because this is set equal to 0, that means that y, or f of x, is also equal to 0, which means that that is where your x-intercepts are going to be, at the x-coordinates of what your quadratic factors to, and then the y-coordinate has to be 0 to remain on the x-axis. So it's important and very pivotal in the beginning of these scenarios to always make sure that your quadratic is equal to 0. Another thing that's helpful here is that the coefficient on your quadratic term, or the x squared term, is 1. Remember, if a particular term doesn't have a coefficient on the variable, you can always mark it as 1 for housekeeping purposes. So later on in this question, this type of trinomial has a very special form, and we're going to look at that, and we'll kind of look at the algebra and generalized form for it and how we can factor it from seeing its generalized form. But what I want to approach here is that we're asked to factor this. So I'm going to approach it in the a times c to sum of b method of factoring. So that's when we're going to take our coefficients, find our a, b's, and c's of our quadratic, linear, and constant terms, and then we're going to find the product of a times c and then the factors that add up to b. So I'll break that down, but what I want to emphasize here is I'm not going to approach this by completing the square, and I'm not going to approach it by the quadratic formula. That being said, the quadratic formula, unless you're told specifically you can't use it, which is a very rare case, that it is always a last resort kind of ace in your pocket. You can use it when you feel like your factoring methods are uncertain, or if you want another way to check your answer to make sure that the solutions you got from one method are in the same solutions with the quadratic formulas method. So to approach this, we're going to factor it by the a times c to sum of b method. So the first thing I need to do is to identify the a, b, and c of this quadratic. So remember, the generalized standard form of a quadratic is ax squared plus bx plus c equals 0. Again, we see that that is equal to 0 because that is where your x values are going to be at the intercepts of the x-axis, because your y-coordinate is equal to 0. Now what we're going to do is go ahead and identify, so step 1 is identify the A, B, and C of your quadratic. So A is going to be equal to 1, because that's the coefficient on the quadratic term, which again kind of brings back the reason of the good housekeeping. B is going to be equal to 6, and C is going to be equal to 9. Now, one thing I also want to bring your attention to is it's not just the values, it's the signs, and that's going to become very important in this approach. So I'm going to go ahead and identify the signage on each of those A, B, and C values as well. So step number 2 is going to be to make our table, representing the left side being the product of A times C, and then the right side of the table being B, which is positive 6. So we have so creating a table with the left side being the factors of A times C and the right side being the value of B. So going a little bit into backtracking of how we approach these, what we're looking for is the factor pair of the factors of A times C that when we add them together equals B. So let's go ahead and create our little table here. So we have A times C, or in this case, positive 9. And remember, I'm going to identify the signage on the value as well, because that's going to be important. And then B is just going to be equal to positive 6. Now, keep in mind and remember for me that factors have to be whole numbers. So the factors that are of positive 9 are going to be whole numbers. But what I also want to stress to you is that remember there are 2 ways that you can multiply 2 numbers by to get a positive number. You can multiply 2 positive numbers, or you can multiply 2 negative numbers. So that's important to keep track of when you're listing all of your factor pairs. So I'm going to start listing all of the possible factors of positive 9 as pairs. So you can have positive 1 and you can have positive 9. Now, do they multiply to positive 9? Yes. Do they add up, or does their summation equal positive 6? No. So positive 1 plus 9 does not equal positive 6. But that's okay. That's just one factor pair, and we still have other opportunities to try. So let's go ahead and let's look at, how about negative 1 times negative 9. So now we're looking at the negative approach to reaching a positive number by having it be a double negative. So negative 1 times negative 9 is positive 9, but negative 1 plus negative 9 again does not equal positive 6. So far we haven't had much luck. Now, one thing you can also keep in mind here to determine your other factors is that 9 is the product of 2 prime numbers as well. It's the product of 3 times 3. So let's try that. So we have positive 3 and positive 3. Now you'll notice that these factors are the exact same thing. That's okay, no big deal. So we have, does positive 3 plus positive 3 equal positive 6? Yes, it does. So this is going to be the factor pair that allows us to reach the sum of B. So this does check. But I do want to take the extra step and show you what happens if we try negative 3 and negative 3. Because negative 3 times negative 3 is indeed negative 9. But negative 3 plus negative 3 is negative 6. And the reason that that is so important is because if we look back to our housekeeping, the coefficient on the linear term, or b, is positive. So even though the value is 6, that's why it's really important to keep track of and take inventory of the signage on your terms just as much as it is the value. So we looked at the constant term, or the c, and we saw that, well, in order to get c, we had to multiply either two positive or two negative numbers, but we also have a summation of a linear term that is positive. So that must conclude that both of our factors are positive. Now in this case, going forward with the question, our factors are the same exact thing. So it's just going to be x plus 3 times x plus 3. But there's a couple things I want to address here. At this point in the question, a lot of students think that they're done because they have solved the factoring portion of this question. They have found the factors that, when FOILed out, will get them back to their original equation. But this question asks you to solve the quadratic, which means it wants you to solve for what the solutions of x are. So what that means is we just have to take an extra step. We're going to take x plus 3, and since it's the same, we don't really have to do it twice, because it'll allow us to determine what the solution is with just doing it one time. But we're going to set that equal to 0 to find the roots or solutions to this quadratic equation. So just like balance scales, equations, when you are trying to isolate a variable, in this case x, we have to undo what's being done to the variable in question. In this one, 3 is being added. So we're going to do the inverse operation of addition of 3, which is going to be subtracting 3 from both sides. That allows me to apply the same weight to the equation, or in other words, keeping it balanced. So even though its display looks different, I'm applying the same mathematical value at the same time, allowing me to solve the equation. Because what's going to happen is the 3's are going to cancel, and x is just going to be equal to -3, which our answer is at the very bottom. But what I wanted to also talk about with this question is, as I mentioned, this has a very special type of factoring method that you can use. This is what is known as a perfect square trinomial, and its general formula is it's going to be a squared plus 2ab oops 2ab plus b squared. Now with this, it has a factored form, and that's going to be equaling a plus b quantity squared. Now you're asking yourself, well, what does a and b mean? Well, it doesn't mean the coefficients on the quadratic, and that's one of the most important things I can mention here, because we see a and b here in multiple contexts. But one of the things that I did to kind of keep us safe here and on track is utilizing capital letters with the coefficients on the quadratic, whereas with this generalized formula of a perfect square trinomial, I'm using undercase. A and b of this generalized formula are going to be the square roots of your quadratic and constant terms. So what we're going to do here, make a little bit more room. So if we look at x squared, I'll put the 1 there, plus 6x plus 9. This right here is a squared. You're looking at our formula here. This is 2ab, and this is b squared. So if I'm trying to solve this equation and factor it proficiently, or more efficiently or quickly, what I can say is to determine a, I just take the square root of 1x squared, and then for b, I just take the square root of 9. So my a is going to be the square root of 1x squared, which is just 1x, or x, and b is going to be equal to the square root of plus or minus 3. So b equals plus or minus 3. Now you're going to have to do a little bit of detective work and problem solving here, because you have to ask yourself, 2ab is equal to 6x. So you have to multiply either positive 3 or negative 3 in this next step to determine your linear term. Now, because we know that the result is going to be x plus 3, we're going to go with the positive, because if we go with the negative, it's going to be minus 6b, or minus 6x. So the a is going to go, so the generalized form is going to be a plus b squared, which is going to be equal to x, or just 1x, plus 3 quantity squared. And that's going to be your factored form. And with these perfect square trinomials, you're going to only have one solution, okay? Because it repeats itself. So the final answer to this question is that your solution to the quadratic is that x equals negative 3. But the factored form of it is going to be x plus 3 quantity squared. And you can set x plus 3 equal to 0. Or you can even do this. You can do x plus 3 quantity squared equals 0. And then you can do the square root of both sides of your equation. And that's going to nullify or cancel out the squared and the square root on the left side, just giving you x plus 3. And then you have that equal to the square root of 0, which is just 0. And then you have your same scenario again, where you subtract 3 from both sides, and you get that x is equal to negative 3. Okay, so just showing you some really special characteristics about this particular quadratic equation, being that it is a perfect square trinomial. But again, in this question, we kind of looked at the very step-by-step approach to factoring this by the a times c to sum of b method, and remembering that if you're not restricted, you can always use the quadratic formula as a last resort to double check your other factoring methods. But I hope this helps you guys out. Please take good care of yourselves and be safe, and we look forward to seeing you in the next question of the day video. Bye.